All right, I'm going to go ahead and get started. I think we're maybe a couple seconds early, but that's okay. People can filter in for the next few minutes. So my name's Jeff Mealiff, and I'm here with Jeremy Kelly and Nasira Ali, both of them from our support group at Microsoft. They're two expert debuggers of performance issues for cases that come into Microsoft support, specifically around the Exchange product. They've been around for a very long time and know where all the bodies are buried in our code bases. So I'm going to be giving a fairly brief overview of how to avoid talking to them. Because I think they would agree that the best support experience we can possibly give you is never having to call support, right? So I'm going to jump into that fairly quickly, and then they're going to come up and walk you through some sample customer cases that we've had that might seem similar to something you've experienced. We've changed the names to make sure we're not going to call anybody out unnecessarily, but it's possible that things might look a little familiar, and we might reward you with a T-shirt if you happen to raise your hand and admit to that. But I'm going to go ahead and jump through essentially how to prevent performance issues in 5 to 10 minutes with Exchange 2013. Much of this guidance also will be applicable to Exchange 2016 as well, and you may see some things repeated from the 2016 deployment session that happened earlier today. It also may be a little bit repetitive from guidance that you've seen from 2010 in the past, and there are a number of reasons for that, right? We've been iterating on our architecture and our guidance for many releases. So let's go ahead and jump right in. First of all, number one most important thing that you can do to avoid performance issues with Exchange is to size your Exchange deployment appropriately. And the best way to do that is with our calculator tool. It's free for everybody. You get a calculator, everyone gets a calculator. The link down on the bottom left corner of the slide takes you to the announcement page for the calculator that provides a bunch of detail about what it does. And there's a download link on that page as well that will get you the Excel file. It's a great tool, allows you to go input your business requirements, essentially, for what you need to get out of Exchange, and use it as a modeling tool. So you can go run various scenarios. If I want to deploy 2 DAGs or 4 DAGs or 1 DAG, change the number of servers, change the type of processors I'm going to use. You can I won't say very easily. You have the ability to go in and see the impact of that in a very quick way and understand exactly what that will look like in your environment. And it can also help actually build those servers for you by exporting PowerShell scripts that will configure the servers, set up the databases, set up the DAG with replication, and get you going. So highly recommend you take a look at that. It essentially will take you from being an IT pro with red tights that can't fly over on the left to being this guy that magically can fly all of a sudden with different colored tights for some reason. So that's the calculator. Scaling up or out. This is another really important thing to be aware of when it comes to 2013 performance. Scaling out is absolutely what we want you to do. Exchange is not designed to scale up. And what I mean by that is that when we architect the product, when we think about how we're going to design the product, how we're going to make decisions about how the product is implemented, we're thinking about a particular hardware platform, and that's the platform that we use for deployment in Exchange Online. We deploy the cheapest hardware that makes sense for obvious reasons. When you're running 50,000 servers, cost matters, right? So yes, we do get a pretty good discount on those servers, but even so, we have to think about costs very closely. So all of our, I'm going to say testing, but all of our production deployment really focuses on what we would consider like a mid-range commodity server. A 2-socket machine, so 2 processors going into the box. Those processors have 10-ish processor cores on them, so about 20 processor cores total. And the machines that we have deployed currently have about 96 gigs of RAM in them. So the closer you can get to that, the better off you'll be from a deployment experience perspective and in terms of reducing risk of running into performance problems. We do see customers regularly run into problems when running Exchange on larger hardware. So just be aware of that. So we don't want scale up. We want scale out. Virtualization. Who virtualizes Exchange in production today? All right. Thank you for being honest. So that's fine. I don't have enough T-shirts for that, sorry. We should get I Virtualize Exchange shirts for the next conference. That'd be great. So key things to be aware of when it comes to virtualization and performance. Absolutely do not use any sort of memory overcommit technology. We're talking about dynamic memory for Hyper-V and any of the options that are available with other hypervisors that allow you to configure a larger amount of memory than you actually have. There's some kind of cool things that a hypervisor can do behind the scenes to make that work. But in order to actually make that work, essentially you're robbing other resources on the machine in order to provide resources to a VM that, for whatever reason, seems to actually need those resources at a given point in time. Exchange doesn't deal well with that. It really doesn't deal well with having resources taken away from it or come back at a later point in time. So from a supportability perspective, with Exchange 2013, we actually don't support deploying with any of those sorts of technologies. And the real key thing to remember about virtualization, just don't overcommit anything. I'm not joking. This is our guidance. You'll actually find that this is VMware's guidance as well if you go look at their deployment guidance for Exchange on their platform. If you want to have a good experience with Exchange on a virtual platform, don't overcommit. Reserve resources. It's that simple. When you think about sizing, size for physical, using the calculator that I mentioned previously, and then add some CPU overhead. Now I'm going to go through a few slides real quick here about balance. And the overriding message is that at every level in the deployment, you want to think about having things be balanced. Having all the different resources in your system and the way that users are consuming those resources being done so in a balanced way. That's the key point here. So at the CAS layer, you want to have a load balancer in front of your CAS machines that is actively making sure that the number of connections hitting those CAS machines is as close to equal as possible across the CAS servers, right? So just like you got the bird balancing on the finger there, you need to balance the number of connections coming into those CAS servers. There's a perfmon counter listed here. You'll see some more perfmon counters in just a second on these other balance slides. You want that number to be as close to the same as possible across your CAS servers or your multi-role servers, which I know you're all deploying. Within a DAG, you also need to think about balance. You want to have an equal distribution of active copies. You want to have more active databases on one server than another. You want it to be as close to equal as possible. Now, for maintenance or for random failovers or switchovers, you'll be out of balance at times, and that's fine. You've planned for that as part of the sizing process, and you're not going to consume more resources than you have available. But the target should always be to have this number of databases mounted be as close to equal across all your servers as possible, just like this person's balancing on a bike. See, these graphics actually mean something. All right, balancing within databases. You want to actually balance the load on databases. So as much as you can, and this is really hard to do, this is even a challenge for us with Exchange Online, you want to balance both capacity consumption as well as utilization in those databases. And in doing so, if you balance the number of active databases across your servers, you will essentially balance the load across all your servers. That's the goal here, right? Now, like I said, this is hard to do. It's easier to do for space, because you can see how much space is being consumed on a database. Harder to do for activity. But there are some ways to attempt to do that if you want to start getting creative and get more engaged. Within mailboxes, so going to a whole nother level, we've talked quite a bit in 2013 about removing some of those limits, some of those concerns about large mailboxes. And that's great, particularly when you're using the latest and greatest clients accessing those mailboxes. However, if you have legacy clients you do still need to be a little bit concerned about the shape of a mailbox. Number of folders, folder hierarchy, number of items in folders, those types of things. As a best practice, you may want to consider actually using the same limits that we do in Exchange Online to try and maintain the shape of that mailbox in a more sustainable way. And you can actually do that via the set mailbox commandlet. So by default, the on-premises version of Exchange 2013 doesn't have any of these mailbox shaping limits. But going in and actually taking a look at what we enforce for the service, running that in your on-premises environment is definitely a best practice. And last but not least, multi-role. So how many of you plan to not run multi-role for Exchange 2016? All right, I got a few of you. Yeah, that's not an option, just in case you missed some of the Exchange 2016 sessions. We've enforced multi-role in the product as a best practice. You don't have a choice anymore. But for 2013, just do it. It simplifies deployment. It's a better utilization of resources. And everybody gets a cupcake for deploying multi-role. So with that, that's all you need to do to avoid having to talk to these guys. However, I am going to invite them up and talk to you for a few minutes. So, Jeremy?
Awesome. Thanks, Jeff. My name is Jeremy Kelly. I'm one of the principal escalation engineers in our support organization inside Microsoft. And as Jeff gave you guidance on the things you should do as part of your deployment, Nasser and I are going to walk you through a couple of the customer examples where they have deployed 2013 but chose a different path and didn't have a great experience. So we're going to there's no better way to learn than through somebody else's pain. So we're going to share that pain with you. And as Jeff said, if you're willing to own up to this pain, or if you've had this pain yourself, we've got a couple of T-shirts here. We might toss one your way. All right. So let's get started with our first customer. And this customer decided to deploy Exchange 2013, 36 cores, 450 gigs of RAM per server. It roughly matched what the server profile is of the rest of the servers in their organization that they're using for virtualization. So they were trying to keep their hardware footprint very similar. One of the things they believed they could do is achieve a higher mailbox density per server. So here again, they were scaling up, not scaling out. It wasn't all-in-one deployment, and then they configured their hardware and network load balancers for least number of connections. But here's what happened to this customer. Towards the end of their deployment, their legal department. How many people despise their legal department? Yeah, okay. Everybody else is the legal department, evidently. Their legal department decided to make a policy change. Basically, thou shalt not have any content stored on your local machine. That's the summary of the policy change. They wanted all content to stay in the mailboxes, no local OST copies, no PSTs, no content, everything stays on the servers. So in order to achieve this, they made a change to Outlook. They configured Outlook to run in online mode versus cache mode. How many people I'm just curious, how many people actually have to run in online mode? Okay. So one of the problems with running in online mode is, if I'm a user, every time I go to the server, I've got to make a request to that server to get that data. So if I change views, I do anything, I'm making a network round trip to that server to go get that data, because I don't have a local cached copy of it. So you can imagine that configuration change driving a whole bunch of new network connectivity requests. Immediately after making this policy change, I think everybody's probably familiar with getting this type of experience in Outlook, right? This is what their user experienced, what they were seeing in Outlook periodically throughout the day. These drop connections, they're not connecting. And now and it was our job now to go figure out what the heck is happening here. It took us about 2 weeks to isolate this problem, and another 2 weeks to actually get remediation in place. Everybody has their policies about change control and et cetera, so walking through that process with their network load balancer team, with their virtualization team versus their Exchange team took time. So, but before I can really get into the deep analysis of this, I'm going to take you on a journey. I'm going to have to share some information with you. We're going to actually dig in a little bit and understand how connections arrived at a server via the network load balancer. So this might be a repeat or just a refresher for a lot of you. Then we're going to double click to the next level. We're going to understand how that connection is handled at the server level. And then we're going to go a step further, and we're actually going to show how does that connection get handed off between processes. So this is going to go deep, and eventually I'm actually going to show you a little snippet of code to show you where the problem lies. So first things first is we want to understand from a network hardware, load balancer, et cetera, how does that traffic get routed? And the first kind of plain vanilla algorithm is round robin. So with round robin, as those connections are coming in, the hardware load balancer is simply distributing those connections to each server in its list. And this process continues until you end up with a pattern similar to the following. So you can see, as Jeff was talking about across your environment, you want to have load. You can see here that my connections are roughly balanced across all of my servers. But there's one problem. Over time, you could end up in maybe some type of situation like this, where a couple of your servers are more loaded than others. And with round robin, it's going to continue to put new connections on those servers, even though that server has more connections than another server in the group. And the reason why this happens is your Exchange connections are different than web traffic. So take for a moment web traffic. When I'm trying to serve up a web page, that connection goes to a server, gets that data, completes that request, and completes a transaction with the web browser. It's a very, very fast operation. In comparison, when an Exchange client connects, that connection can be long-lived. It could be several minutes to several days, depending upon the traffic pattern of that client. So that connection is very, very sticky. And therefore, depending upon the client profiles and what's connected to the servers, you can naturally end up in this type of situation. So the question is how do we fix this? Well, we can go to another algorithm called least connections. And with least connections, with least connections, the network load balancer is going to take those new inbound connections, and it's going to route them to the servers that have the least number of connections. Simple, right? So as the traffic is coming in, it's continuing to add these connections to those servers until it becomes fully balanced across all the servers in that you have configured. Now, there's one problem here. You want to guess what happens? Add a server. So what happens if, let's say, one of my servers was down for maintenance? Either hardware failed or for some reason it was taken out of rotation. What's going to happen? Every one of those new connections are going to come into that one server at a time. Now remember, Exchange traffic is a different pattern than normal web traffic. These connections are not short-lived. They take time to set up. They take time and processing power that a normal web connection does not typically require. Therefore, I just overloaded the server with a bunch of new requests that has to go figure out how to manage and set up all these connections. Now, here comes the next step of this. Now that this server has become busy, components like managed availability will now step in, and its managed availability probes will poke at the server and say, hey, you're not responding. I'm going to take action to restore the health of this machine. So guess what? Managed availability is now going to take that machine out, restart the services, and guess where your connections are going to go? It's going to get redistributed until that machine's back up. Now I've reintroduced another machine, and it's going to end up being this kind of potentially roving outage problem. So how do we fix that problem? So least connections with a slow start component allows those connections to arrive at a server in a more distributed fashion. It looks a lot like round robin initially until the servers, until all the connections come in and we end up with a fully load balanced scenario like the following. And then when a new connection comes in, going back to our scenario where we just restored a server, when that server is brought up, with slow start, those connections only one connection will get deposited on that server. And this is just for illustration purposes. But I'm going to continue, the load balancer is going to continue to distribute those connections against the other servers. And then instead of one connection in the rotation, it will now be 2 connections. And then on the final rotation, it would be 3 connections. So you can kind of get the premise here that it's going to slowly add connections until the connections, until it's load balanced across all the connections, all the servers. And the result here is with least connections with slow start, we actually get a faster convergence across all servers. So those connections come together and balance across those servers much faster than something like round robin. So our guidance here is, if you have no other option, round robin. Really, least connections with a slow start component is what we recommend for these reasons. Each hardware manufacturer is going to have a different kind of formula or a different flavor of this. And you'll have to work through your hardware manufacturer to understand what those differences are. So, with that, now we have connections routed to a server. Let's take a deep look at what happens when that request hits the server. So we're going to look across the different processes. Now keep in mind, this is all just a staging so that when I get into the analysis part of this customer scenario, you have the context. So here, the connections arriving in IIS. So everybody remembers there's the front-end component and a kind of a back-end component of the legacy kind of CAS model. So we have that connection coming in on port 443, and our IIS or HTTP sys is going to accept that inbound connection. It's going to hand that connection off to an instance of what's called W3WP. You ever looked at your task manager on your server and saw all those W3WP processes? Well, this is what it's doing. You're going to get a different instance of W3WP for every set of protocols the server is processing. So you'll get one for like you'll get one for EAS, OWA, etc. So in this case, we're looking specifically at a typical inbound RPC request coming from a client. That first request is routed to what's called the RPC front-end app pool. Now there's some changes in CUs, and I can't remember exactly which CU we made this change in, but we broke out these responsibilities, but this is, if you install the latest CU, this is the experience you should see. The request is routed to the front-end app pool, where the RPC HTTP component is going to strip off all that HTTP overhead. It's going to surface that request. Specifically, it's going to be looking at the GUID at contoso.com, the GUID of the mailbox at contoso.com, where HTTP proxy is going to pick it up, and it's got to figure out where the heck is that mailbox, which database is that user on, and where's that active mailbox. It's going to do a lookup against the mailbox replication service to locate that mailbox in the topology. And then that mailbox could either be on the same machine or a different machine inside my environment. And so it's going to route that request either back locally through IIS or to a different machine of report 444. At that point, the connection arrives at the W3WP instance called RPC Proxy App Pool. This is where we once again strip off the HTTP information and we surface the actual request. We pass that along to the RPC client access process on port 6001, which knows which database which knows which instance of store worker process to hand that request off to, and eventually it'll land inside that individual's mailbox. Okay? So now, it's time to double click again, and we're going to dig down a little bit deeper and understand what happens between IIS and one of these W3WP processes. Now keep in mind, we have a customer that's having a problem, and this is the level of analysis we're trying to do for this customer and some of you if you called into support to help get to the root cause of this problem. So let's take a look at this. So once again, we have a connection come in. So at the IIS level, that connection arrives at the arrives at the RPC endpoint. And there's a component inside IIS called Connection Manager. All it does is accept the inbound connection. And then there's a component inside IIS called Request Router. And what Request Router does is it looks at the RPC and the port number, the URL and the port number, and says which instance of W3WP is registered to accept this traffic. In this case, we care about the RPC front-end app pool. And so it routes that request into what's called a W3WP queue and continues to route new incoming connections into this particular queue. What's going to happen at this point is a notification is going to go to the proxy front-end app pool, and those connection information is going to route and be picked up by a thread running inside W3WP that will now process that request. In the meantime, all of our threads are now executing and processing requests inside W3WP, and we have new inbound requests coming in. And those continue to be queued until W3WP is ready to pick them up. Now, these connection requests that are sitting in W3WP, they have to know what to do. What am I processing? And what happens here is each one of these threads is going to try to access a piece of memory called a system.web.buffer. And what's in here is essentially all that. If you ever opened up an HTTP request and you see all of these different headers and protocols and pieces of information, all that stuff is stored in one of these buffers. And so it's going in, it's pulling that information out to figure out what the heck am I supposed to do with it. Now, I can't have hundreds of threads accessing the same block of memory at the same time. So we have to put a lock on it. We say, you know what? Only one thread at a time can go in, grab that data, and then once you've got your data, you move on. So we have to put a lock on it. So if all my threads are currently processing requests inside W3WP, I'm still getting connection requests queuing inside IIS until it reaches a maximum right now of 65,000 connections waiting. Now, what happens if that queue fills up? You get disconnected. So go all the way back to the first experience slide, you start seeing disconnects. You can tell if that list is full. How many people look at the protocol logs? Have you ever looked at protocol logs? Awesome, more than I thought. So inside Exchange, we produce a lot of logging, and a lot of this is a byproduct of what we do in the service, where we use this logging to help identify and proactively troubleshoot issues. One of the things that we could do here is we can actually open up these logs, and you can see from the logs, connection dropped list full. This is where it says, hey, I tried to put a connection into the queue, and I got an error message. So keep all that in mind. And just for reference, if you're not familiar with logging, just for RPC, here's the pipeline of logging, the order in which you would want to look at it. I've added this to the slide deck so that when you go and eventually download this, you can have a copy of it. But here's the order of the log files, and you can parse through those log files and try to follow connections going through. This is something our support engineers do quite a bit of when troubleshooting issues. Okay? So now that we have a kind of a solid base of understanding about the scenario, now we have to actually troubleshoot this issue. What's going on? And whenever we're troubleshooting performance issues, we always look at the 4 key resources: network, CPU, memory, and storage. And we try to figure out which one's the bottleneck, where's the problem lie. Now, unfortunately, sometimes we need to understand what's normal. I don't know what's normal for your server. Sorry to pick on you, but you're looking at me. And I don't know what's normal for his server or her server, etc. So we have to understand what's kind of the baseline. How many connections do you have on average? How many has that changed? What's been the average response time, and how has that changed over time? So in Exchange, we actually have these daily performance monitor logs. So we keep 24 hours of data, or we keep 7 days worth of data, and we cycle this log every 24 hours. And this at least gives us some indication of trend over time. And hopefully in your environment, you may have either reconfigured this or you have some other type of monitoring solution so you can go back further in time to look at this. But it's incredibly important, particularly as we try to troubleshoot issues. So the next 4 slides, we're going to look at each one of these resources. And what you're going to see on each of these 4 slides is some recommended high-level performance monitor counters that we look at inside support if you come to us and say you have a performance issue. On the slides is some guidance. Look for a value of less than 100, in this particular case for RPC average latency, look for a value of less than 100 milliseconds. If you don't see a value listed here, then that's an indication you should look at your historical trend and see how that is changing over time to troubleshoot the issue. So the first thing we're looking at here is what's called RPC average latency. So if you'll remember in our pipeline of client connectivity, there was a piece of the component called RPC client access. And what this is actually measuring here is when that request comes into that process, gets data out of that mailbox and sends it back down the client connection pipeline. How long did that one particular operation take? And what this allows us to do is quickly troubleshoot and narrow down the problem. Is it between A and Z? Well, now is the problem between A and J. We're constantly trying to narrow down the problem. So by understanding the pipeline of the client request, we're able to narrow down where that problem lies. So here we just look for a value of 100 milliseconds, so we can see that this one's okay. Memory usage, same thing. We're going to be looking at memory usage. We want to see, how is this box under pressure or not? In this customer's case, remember they had 460 gigs of RAM. They're only about 30% committed. That means there's only 30% of the memory on that box actually has real data that we care about. We also look at things like .NET performance counters. It's particularly around garbage collection and allocation rate. And this informs something called workstation GC versus server GC. For the interest of time, I'm not going to drill into this because I could spend a whole 75 minutes just talking about how that algorithm works. But if you have questions about it, Nasser and I will be at the booth for the next hour or two following this presentation, and happy to drill down into that level of detail with you. But essentially, we're looking for these counters to figure out what's the performance. Is there particularly a performance issue around memory usage? Next, storage. How long is it taking to get data to disk, and how long is it taking to get that data back off of disk? And so there's a lot of guidance here about those particular counters. In this customer's case, we looked at the I/O, looked pretty normal. Whoa, wait a minute. Now we're at CPU. Anyone see the problem? In this case, we have to look across all the instances of W3, WP, and we found this one instance, WP, W3, number 3, the third instance, which actually represents our RPC proxy front-end app pool. And it's running at 100% CPU. Now, at this point in time, the real question is, gosh, what the heck's going on inside that process? And this is where I have to leave the area of kind of traditional IT pro, and I have to put on the developer hat. I have to figure out what's going on, and we typically have to figure out what's going on inside that process. And one of the tools that we use to do that with, or there's 2 methods that we typically use to do this. One, it traditionally has been a user dump. And a user dump is kind of like a photograph of the process. Stop everything, write it to disk, then move on. And from that photograph or the snapshot of the process, we make an inference of what happened prior to the dump and what's going to happen after the dump. And inside this dump, we have information about all kinds of processes and threads, et cetera. And sometimes we have to take multiple snapshots of that. The unfortunate thing is it's also very time-consuming and impactful to users. Another tool that you might see us use and support use quite frequently is called PerfView. And PerfView just uses some tracing that allows us to figure out things like hot code path and where time is being spent. PerfView is not a Microsoft, or is not an internal tool. It's actually publicly available. You're welcome to go download it and play with it. You're going to enter into the realm of development as you play through it. However, in this customer's case, I'm just going to move on just a little bit. One of the things we noticed from the PerfView is this, what's called a hot code path. And this is a call stack. And one of the things that we know, the way you read a call stack, this is what's happening on an individual thread. At the bottom is start. You start at the bottom, and the most recent or the currently executing code is at the top. Looking across all of these threads, we saw that this thing called get buffer or release buffer was rather prevalent. So the question is what's going on now? All right. Sorry, this is where we jump into source code a little bit. This is all publicly available source code. .NET Framework is open source now. So I'm allowed to show you this. But you'll notice that going back to this call stack at the, I forgot where's the laser. At the top here of the call stack is these things called locks and stuff like that. If I look inside the source code, you can see this where I've yellow highlighted this thing called lock. And that's where we're locking that information. And then you can also see one of the things that Jeff and what you've heard probably throughout the week is, exposing those cores. When you expose those cores, we make decisions about how we run the server based upon what's in that side. So if you look up here, actually, I'm going to if you look up here, what's that doing? What's that piece of code doing? Get the number of CPUs on the box. So when you expose those CPUs or those cores to the code, we make decisions about how we scale up and scale inside the process. And sometimes those decisions govern how we behave. And when we design software, we're designing it to the hardware platform he indicated, not necessarily to a scale-up situation. So that's the reason why it's important. So let me wrap this up, and I'll hand it over to Nasser. Just to recap, what was happening in this customer case, and we had to go through this analysis. Investigation took us about 4 weeks. There was a couple of things that the customer didn't do. One is, from a preferred architecture standpoint, really they scaled up beyond what we typically test with inside the service. The other thing is the network load balancer wasn't optimized for exchange load. So they were using least connections. And so every time that the processes would cycle, they would have a bad experience and have a batch of clients that would disconnect. So what would happen here is when this large number of connections arrived at the server, that process, that front-end app pool was becoming overloaded with all these new connections. It was taking a long time. It was getting bottlenecked because of the buffer size that we were allocating based upon the cores that were exposed. Managed availability probes kicked in and said, you know what, you're not responding. I'm going to take you out. I'm going to restart you. I'm going to try to restore service to these clients as quickly as possible. By taking the process out of rotation, the network load balancer says, hey, you're offline. I'm going to stop routing connections to you. And as soon as that service is back up and running, the network load balancer, what did it do? It dumped a bunch of connections onto the box. And thus the cycle begins over and over and over again. So for this customer, in order to resolve this, one of the things we did was work with their vendor for configuring this to a slow start out, to include a slow start component. We also worked with them to reduce the number of cores exposed to Exchange to less than 20, which is what the guidance, according to our preferred guidance. And then obviously there's some scalability improvements that probably need to happen around the system.web buffer. And the .NET team is committed to making some of those improvements in .NET 4.6, which is currently in preview. I'm going to say we don't recommend you go install that. We don't recommend you install .NET 4.6 or even when it's released. When we will provide guidance publicly when we feel like that we are comfortable with that release, and we'll share that more broadly. So keep track of that on like the eHello blog. I'm sure we'll publish that information there. So with that, I'm going to hand it over to Nasser.
Well, thank you, Jeremy. My name is Nasser Ali. I'm a principal escalation engineer, also in support. I got exactly 20 minutes to go through another customer study, so I thought I will just use the HoloLens to show you what it works actually and how it does things, Just kidding, it's not there yet. But hopefully in the future we will have something like that to make the troubleshooting a little faster, So in this particular case, what's going on here? I think we do need the, all right, here you go. So this particular case study, actually, again, we're looking into a customer that called in, and the customer called in, it's a crit set. How many of you know what the crit set is, actually? Okay, so you probably know what crit set is. It's basically the highest level of attention we need, customer down, all hands on board type of things, and continuously looking into the situation. So this particular customer, obviously, when they were looking into this particular problem, they have the similar type of issue that Jeremy has showed earlier, connection, disconnection problem, and then the end users are not having a good experience. Particular customer actually migrated from Exchange 2010. They moved to the 2013, and they did not experience. What they were hoping was that it will be a smooth transition, great experience, faster times, and all those things was not happening. And if you look into their hardware configuration, they're actually following the preferred architecture pretty closely. I mean, 16 core, 92 gig of RAM, and all-in-one configuration. So this particular customer actually follow the preferred architecture, not all the way up, but pretty close, And what they were noticing is that when the call come to us, we continuously having these problems. And we don't know why the clients are getting disconnect. And it happens certain time of the day, sometime in the morning, sometimes in the afternoon. We don't know why it is happening. So when we start digging into these things, we start digging into it, we start collecting the data, which is basically the performance data, event logs, and some of the other things. We start noticing is that, okay, the disconnection that you're having is because your database is actually failing over between the nodes, so we can correlate that, okay, well, it is failing, you're having disconnect issues because it is failing over the databases, and then that particular server is overloaded because a lot of databases move to that other server, and that may be the reason that it is coming in. So, okay, well, why the database is failing over? So that was the first clue that we looked into from the event logs, actually, to figure out what is going on. The next thing that we start looking into is that, okay, what is your overall configuration of the server looks like? Obviously, there was an antivirus in there, and the other things that we looked into. So we start asking the question is that, okay, well, let's start looking into see what it is that we need to do in this particular case to figure out what's going on, right? So we start looking into, there is something called Crimson logs, which basically associated with managed availability. That's the first clue we look into to see why the database is failing, why there are certain probes that are failing and things like that. And I will cover a little bit of managed availability here to show you what it is, but there are a lot of other details available. All right, so let's go to the next slide. Okay, here we go. All right, so the first thing that comes to mind is that, okay, well, what's happening in this particular case? The customer also indicated that occasionally they get a blue screen. This is a blue screen of death, coming in. So, okay, we're getting a blue screen on this particular hardware. What is there a driver issue? Is something else is causing the problem? What it is? So one of the blue screen came from as a part of data collection to us to analyze. We start analyzing it, and we figure out that there's something going on within this particular environment, especially with the AV filter driver that's basically blocking the IOs. So what's happening is that it's taking a lot of time for the IOs to come back, and because of those delayed and installed IO, managed availability, sometimes moving the databases, sometimes it may restart the server and things like that. So the first thing that comes into mind is that we have a proof that there is something IO-related issues going on with your antivirus stuff. Can we uninstall it? Customer says, yes, we will uninstall it to help you investigate it further. They uninstall it, but they basically disable it. They did not uninstall it, they disable it, right? But in our mind, it is uninstalled. So everything is looking good. One day goes by, they say, we're still having the same problem. We have taken care of the AV, and it's still the same problem. We got a second set of dumps from them. We looked into it, and filter driver is still there. So the question was that, okay, well, did you uninstall it or disable it? And it just comes out, oh, we actually disabled it. And disabling it does not actually remove the filter driver from here. The filter driver is still there. And as a part of the thing is that even though it is not doing some of the other stuff, it is still sitting into the stack, it's still looking into each of the I/O, and it's still doing a lot of other stuff, right? So we moved on. We say, okay, let's go ahead and uninstall it completely. Then we make sure that there is no filter driver associated with that particular antivirus is there. It's a very popular antivirus, actually, but I'm not going to name it. All right. So this actually helped stabilize the customer environment. I mean, it comes to the point where we thought that, okay, this may be the root cause of this particular problem. But they continue to see some of the issues, I mean, the frequency got decreased, but it is not completely resolved. And so this is part of the managed availability thing that I was talking about, and part of the thing is that now what we're starting to see is that their IIS, their app pool associated with some of the W3W process are getting started, restarting the service, or some of those things. So now again, going back to the managed availability, it's not the blue screens anymore. It is not moving the servers. It is basically now comes down to the point where the IIS or the particular app pool is getting restarted. Some of the services are getting restarted, and it happens during the time when the connections are coming in, when the users are coming in or when the users are seeing the issues. And part of the managed availability is that, as you can see, is that I'm not going to go into the details. There's tons of information available on this thing. Managed availability was new in 2013, but we are on CU8 now. And a lot of information about managed availability is outside available. There's tons of script available that allow you to enable, disable certain things. Managed availability is a health service. It monitors all the processes and different things that's going on within the system, and kind of provide a continuous feedback or synthetic transactions to find out how the server health looks like. So it looks into the performance counter and event logs to figure out what it is. So we said, okay, well, there's something going on with this particular W3W process, so let's figure out what is going on in this situation. So we move on to the next step. We start looking into the performance analysis to figure out what is going on here. Storage looks fine. As Jeremy has covered, these are the things that we looked into. So storage, okay, but is this something to do with the storage? Is storage causing the issue? In this particular case, storage seems to be fine. We don't see anything related to the storage that may be causing the problem, right? So we'll say, okay, fine, the storage is fine. One of the things also comes into that discussion is that asking the customer what is your baseline looks like. In majority of the time, we don't get a confirmation from the customer that, okay, this is my baseline looks like, this is what my expectation is, what should work, and this is what I do. And the other thing that we generally ask is that what changed? And generally the answer is that nothing is changed. Okay? So you guys all know that what I'm talking about here. So looking into the storage performance analysis, we figure out, okay, there's nothing wrong with the storage actually. It's working fine. Okay? Let's take a look into the CPU, and then again, we notice that there is a high CPU going on on W3WP instance number 11. It is running hot. And why the CPU is taking so much of a time? High CPU, it's almost taking 3 or 4 cores, and it is running. And generally, it should not be running that hot. Is this server underperforming because the hardware is not up to the par, or is there something else? That discussion comes in. Is it really they put more users on this particular thing? Do we need to scale out further, reduce some load on this particular server to find out what's going on in there? And it doesn't seem like that there is enough, the users were distributed fine. So it doesn't seem like that there is an issue with server being underperforming, because of the load. But this gives us the first clue that there is, after peeling the onions. So as you notice that there's multiple issues that we are dealing with. It's not one issue. We fixed one issue, we think that, okay, it's fixed. It come back again. So we start looking into this thing and say, okay, well, CPU is running hot on this particular thing, and managed availability, when it looks into it, it is restarting the service because it is not getting the synthetic transaction done on a proper time. All right. The second piece we look into is basically kind of, okay, well, the memory is up. So what is the deal with the memory? And then one of the tall tale sign of a memory leak is that you see the stepping. Look into the red line, which is showing you the memory associated, and you can see that it is a step up process, and it seems to be stepping up till it comes to the point where it is at a higher, a lot of memory actually, I would say. And then you see a drop. The drop is there because the customer basically either restarted the services or reboot the box, So one of the things customer was saying is that, well, it seems to work fine, and then in 2-3 days, or sometimes in the same day, depending on how things are going, we just restart the service and it seems to be working. That's a great workaround, but we don't want it. We want you to fix the problem. So we say, okay, let's continue, start looking into this particular problem. Now we have two things. We see the high CPU, we see the high memory usage. That kind of indication that there is something wrong with this particular process, W3WP process, which is basically the front-end app pool. Okay. So what I'm going to show here is that what it looks like when you start a W3WP process. How many of you know what an app domain is? Okay. I can tell you whatever I want, and nobody will will know the difference actually. All right, it's great. So as you know that majority of the processes, or almost all the processes in Exchange 2013 is managed. And as a part of the managed process, they kind of get created in a particular app domain. App domain is kind of a container that keep the particular process running, right? And in a typical Exchange 2013 process, W3W process, or any managed process, you will see around 3 to 4 app domains. Now, each of the app domain is basically kind of, you're looking into, has the information about, what are the binaries that are getting loaded into there, what type of configuration files that you have, what is the virtual directory that you have. This kind of a container that has a configuration as well as what the process is actually doing. So it is a mini memory snapshot of that particular process. Around 150, 140 meg of memory, So we start looking into, say, okay, well, we need to get more details on that particular process. Now, as Jeremy talked about in this particular case, there are certain tools we might ask you to provide as, user mode dumps or IDNA or perf views and things like that, In this particular process, at that time, we were looking into the user dump, and we did not see actually a lot of things going on in there. We cannot figure out what's going on in this particular scenario, So the next thing that we do is, okay, well, let's run this particular process in Process Explorer and try to figure out what it is. As soon as we start monitoring the particular process, we start noticing that there is app domains associated with this particular process, which is large. And when you look into any other, the same process, even in my demo machines, I see 3 or 4 maybe, not more than that. So we think that there was something wrong here with the app domain. So, we consult with our with our .NET Framework team and find out why these app domains are getting created. Do you have any idea? And then the information comes back in that is that anytime a configuration change can happen in a W3WP config file, what normally happens is that IIS will basically says, okay, well, you need to create an app domain. So basically the new configuration changes that you have put in get into the production. So we say, okay, so looks like there's something changing in here that we need to figure out what it is. So we still don't know what the root cause is, but we're getting closer and closer to our investigation. We can correlate number of app domains are high CPU, high memory. In the same time, we also notice that when we're looking into the application log files, this particular logs is coming in every 15 minutes. Every 15 minutes, this application log is coming in, telling us there's something got changed into Outlook Anywhere configuration. Now, why would somebody change every 15 minutes? Is it a third-party application that may be coming in and changing it? Is there something, a script running that may be changing it? What it is that's causing it to change? We know that the change is coming in, and somehow something is changing into the RPC HTTP, and that may be causing it to have the app domain to grow up in size and things like that, right? So now we come to the point is that, okay, well, who's actually changing those type of information and why it is doing it, As you notice that this particular log is an informational log, although the information in this one is really critical to solving this problem, but it was an information. And guess what happened when you start troubleshooting? Do you look into the informational events or you go to the errors? We go to the errors, right? So this one got overlooked. Nobody looked into it till we come to the point where it's, okay, let's look into during that time when this issue is happening and see what type of logs or event logs are getting generated. So this kind of, we pulled that information from there. By the way, customer was still having the same problem, and we were looking with them to figure out what it is, All right, so let's take a look into understand what is the app domain leak is. It's basically give you some idea that what's happening in this particular case. And the reason I'm showing you here is that so that you can get a better idea of what happened in terms of when things are not working right. So generally, what happens is that when you get a number of users coming in into the morning around same time, 100 users, 200 users, whatever the numbers are, they're coming in and they're going through the front-end app domain and then basically going through this RPC app pool and connecting to the RPC client access and then basically going through this. As a part of the initialization, notice that the config binaries, connection, and heaps, all of that things are created into the app domain. So that's basically your memory footprint of 125 megabyte that is getting at a startup, right? Ideally, there should not be more than 2 or 3 of these app pools. So you should be limited to maybe 1 gig of memory, 2 gig of memory, 3, 4. 20 or 18 gig is something that is really, really red flag. There's a lot of memory. There's something going on in that particular process. All right, so users get connected, and what's happening is that we figure out that there's another service which is called my MS Exchange Services Host, and that particular service is basically responsible for doing some minor update tasks and things like that. And as a part of those tasks is basically changing the web configuration file. So we figure out that particular piece by running into the System Explorer and things like that to find out which particular process is actually making the changes into the web config file, and then figure out why it is supposed to be making those changes because it's really not needed. That information should not be getting updated. So service host file is coming in, updating every 15 minutes. And every 15 minutes when it comes in, got it, okay. Every 15 minutes it's coming in, and it goes in, and a new app will get created. And then things comes in, another app will get created. So every 15 minutes, a new app pool is getting created, right? Now, generally, the .NET framework will take care of any app pool that doesn't have any work associated with it. It will terminate that particular app pool, so you will recover the memory. So in this type of situation, if the type of connections coming in are short-lived connection, then what happens is that app pool will get terminated, and then you really just have a 4 or 5 app pool that's working in. In this particular case, these are RPC app pools. So basically what's happening is that these are long-lived connections, So the first 100 users that came in were still using the front-end app pool from the first one. While the second set comes in, you start using the second one. The third one comes in, and then start using the third one. So basically what's happening is that, let me go back one slide. So basically what's happening is that every time the new app pool is getting created, the previous app pools are not getting terminated because there's a users associated with it, there's a connection associated, there's active work associated with it. So at the end, what happened is that because of all of those generation of these new app pools over a period of time, it will start accumulating memory. And as the memory starts accumulating, the CPU associated with a particular process starts going up. So what we are seeing here is that it's actually a memory leak that we find out in this particular case. Now, once we determine that it's a memory leak, MS Exchange Services Host is actually doing some of this stuff, and we kind of do the code inspection. I cannot show you that particular code because it is Exchange related, it's not public. But believe me, we looked into the source code to figure out what it was doing it. So once we figure out that particular piece, then the next step was to basically do the analysis. As you notice here is that it's particularly in this particular case, there are like 3 or 4 different issues comes in. And we really have to peel the onions in starting with, okay, disable this, and then figure out what the problem is. And the continuously data collection and analysis loop till we come to a point where we say, okay, well, this is the root cause of the problem. In this particular case, there were multiple root causes. What Jeremy covered earlier, they were using the round robin, but they were not into the slow start. So basically what happened is that initially when the machine was blue screening and things like that, they would start seeing those domino effect of users coming in and then all those different things associated with it. So there's a change that needs to be made over there. So the other thing is that a lot of the stuff that customer experience and call us, sometimes they're already fixed in the current CUs. I mean, or like if you look into the CU8, and if the customer has the latest CUs applied to their environment, a lot of time the issue is already fixed, and as soon as those things comes in, we say, okay, well, this is a known issue and it's fixed in the particular CU. Go ahead and apply that CU. That will take care of the problem. So the key here is that not on the latest CU. And then the other thing is that not having the performance-related fixes that we have in 4.5.2. This particular customer was in 4.5, and they have not updated any of those CLR-related things. So it is key here is that keep yourself on the latest CUs, and then make sure that the associated things that we have, the supported thing, like we know that there's a performance fixes in 4.5.2, so let's go ahead and apply those things. And in this particular customer case, basically they hit a bug in the product actually. So when they hit the bug, actually we open a bug with our product team, providing the analysis that, okay, this is what the problem is. Fix was fairly simple. Why they should not be doing those type of changes, requested. And as a result, the fix was provided in, I think it was in SP1 or the CU5, one of those places, And once we provided all of those things, balanced this particular customer, they had no problem. It was worked very smoothly. The end users have great experience and no issues after that, So that was the conclusion on this particular case study. I hope I have explained and show you the workflow that the escalation engineer goes through. We do use some of the internal tools, but the basic troubleshooting or the basic research is start from perfmon, event logs, and things like that, which is also available for anyone to look into. However, there are certain resources that are, help you do the automation. There's a lot of things available in Exchange 2013. I think it is a version of Exchange that has so much of logging that sometimes it is an overkill. Sometimes you cannot process all the logging that's getting generated. So the part of the thing is that can you automate some of that stuff? And that's where I put some of the information related to resources here that kind of you can go back and look into and see when you're troubleshooting these type of issues to start with over there. To see what is the performance counter I need to be monitoring. What are the different things that I need to do troubleshooting? How many of you have used XMON? Okay. How many of you have used XMON on 2013? No hands? Oh, it's not available, sorry. So XMON, we are working on some of the tools, and one of the things that we are doing is that we're looking into the troubleshooting tools that we have it in the past available that have good experience, and some of those are coming in, as well as a lot of new stuff is coming in terms of scripts, in terms of data analysis that you can use to expedite your performance data. When you call Microsoft and then you have all of those information available, it make it our job much easier to go through and look into the performance data. Because believe me or not, if you get all the data and the data is not from the right time where the problem is happening, that data is basically useless. We spend hours and hours to figure out, okay, well, it is not really showing any issue because it was not taken at the time when the problem was happening. So these are all the resources. I have it here. These are related sessions. Some of the sessions you already done, so you can look into those sessions and look into the recording. Basically, it talks about all of the different things that you can do in terms of performance, in terms of how you can optimize your Exchange server to have user good experience. We like your feedback. The best thing to do is that don't look at anything else. Just go through your survey and just hit 5 on everything. That's the best. That's the best. All right, and then the other piece is that provide some feedback to us. How you like this particular session? Was it give you enough of information that you can take back to your jobs and look into some of that stuff? And the last thing is that basically, we will be at the booth. Me and Jeremy will be in the booth today after the session. So you come over and talk to us. Jeff will be there tomorrow.
Yes.
Tomorrow Jeff will be there, so we can look into it. Thank you.
In the middle.